All right, guys. Welcome to Math 410 Elementary Algebra Lecture 8. Today's date is supposed to be November 10th, 2021. You will see why I'm recording this in your email, so please take a look at that. All right, let's get started, guys. So, Lecture 8, we're going to cover a few sections of Chapter 9. So, Chapter 9 is the further solving, 9.3 further solving equations. So, in this lesson, we're going to go ahead and see how does it get further? Like what we know that when we solve for x, we get x equals a number. We know it could be a positive, negative, whole number, zero, a decimal, a fraction, right? So we've seen it all. But the point of this lesson is to show you that there's actually other cases of equations that we need to be on the lookout for. And this is what this lesson's about. So let's take a look at this equation here. So remember, pause it, just have a moment to copy this down, and then press play as I walk through this, because in class I normally give you wait time to write the problem and to work it out. But in this video, you have control of your pace, so make sure you pause and play as you move along in this lesson. So the first thing we're going to go ahead and get started is we're going to go ahead and follow the steps of solving the equation. So the first things first is draw the line down the equal sign, right? And then we're going to go ahead and do any distribution and combine like terms. Okay, that's step one. So we're going to distribute this negative 2 over here to the right side. So negative 2 times x is negative 2x. Negative 2 times negative 5 is two negatives make a positive 10. Bring down the plus 10 equals. We're going to go ahead and distribute the negative 3 to the parentheses. Negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. And bring down the x. We'll go ahead and show you what the like terms are. On the left side is the tens. And on the right side, we can combine the x's. Let's go ahead and simplify that for me, okay? So plus 10 gives us 20. Over here on the right side, you owe me 3x and you pay me off an x. So you have one x on you, but you owe me 3. So then after you give me the one that you have, you now owe me 2. So now we have here negative 2x plus 20 equals negative 2x minus 6. Remember, our goal is to get x's on one side, so I'm going to go ahead and add 2x on both sides. Notice that the two x's are both opposite, so this is going to be 0. This is going to be 0. They're both going to cancel out, but we're left with 20 equals negative 6. This is a mathematical statement, y'all. 20 equals negative 6. Now, a mathematical statement could be true or false. Does 20 equal negative 6? It does not equal negative 6. So this is a false statement. When we get a false statement in an equation, guys, that's going to be a no solution. What a no solution means is there is no number that we can plug in here and get the left side equal the right side, because we're going to get a false statement no matter what x value we pick. There's no x's, you know. We did the problem solving steps that we know to do, but we got a false statement, which means it's a no solution. So now, what does that mean moving forward in this class or in mathematics? It means that whenever you solve an equation, you want to be very careful of your steps, because wrong mistake and you get a false statement, you're going to put no solution. What if there was a solution? You want to make sure your algebra is on point. Hence, take advantage of these practice problems. Here's your first practice problem, guys. I'm going to go ahead and pause it here, write it down, and try to solve it. See what you can get to. And then press play to watch me work it out, okay? I'm going to work it out. This is a practice problem, so I'm not really going to explain anything. I'm just going to go ahead and solve. You can rewatch this part and see what I did. 5 times 2 is 10. 5 times minus x is minus 5x. Plus 8x equals 3 times x is 3x. 3 times minus 6 is minus 18. No like terms here. I can combine the negative 5x and the 8x here, which gives me positive 3x. So it'll be 10 plus 3x equals 3x minus 18. Subtract 3x on both sides. 0, 0. We get 10 equals negative 18. 10 negative equals negative 8. That is a false statement. So this is a no solution. Just like the example earlier. Alright, let's go ahead and find the next example, guys. Example, solve this equation. Let's see what happens, alright? So we know how to solve equations at this point, right? So let's see what happens here. So then we get 3 times x and 3 times negative 4. Remember, pause it to write your own problems down if you need the time. So 3 times x is 3x minus 12, right? Because 3 times negative 4 equals 3x minus 12. Well, notice here we're going to go ahead and subtract 3 x's on both sides. Because remember, we want to get x's on one side. We're solving an equation, so solve it. They both cancel out, but we get negative 12 equals negative 12. Ah, that's also a statement, but this one happens to be what? True. And when we get a true statement, there's no x equals a number. This is a true statement. What this means is there's an infinitely many solutions. Infinitely many solutions. So what does that mean in algebra? That means infinitely many. Any number you can think of, you can plug it into x and you'll get the correct answer. Like for example, let's plug in 4. Let's plug in 4 for x. So if x equals 4. 4 minus 4 is 0. 0 times 3 is 0. So this is 0. 3 times 4 is 12. 12 minus 12 is 0. True. Let's do 5. 5 minus 4 is 1. Times 3 is 3. 3 times 5 is 15. Minus 12 is 3. 3 equals 3. Notice how 4 or 5 work. All of them are going to work, guys. Infinitely many. It's actually a beautiful thing when you get this scenario. Because it makes you use your logic in math. Like, what do you see? What do you read? What do you hear? So let's go ahead and move on to the practice problem, guys. Now remember, this is a practice problem, so I'm not really going to explain this. Pause it here for you to work it out. Press play when you're ready to see me work it out. So first things first, draw the line on the equal sign. Distribute your negative 6. So then we get negative 12x minus 6 minus 14. Then we get negative 10x minus 20 minus 2x. Combine your like terms. Here we have the x's. And the left side we have the constants. So let's simplify here. So we get negative 12x minus 20. And then over here we get negative 12x minus 20. Notice you just get the same thing already. You can probably stop here, but I don't want you to stop because in college I want you to show me the mathematical statement. That is a statement, but remember we want to solve for x, so we want x's on one side. So show me that you know how to get the x's to one side. We get a true statement, which what does that mean in algebra? It's infinitely many solutions. Alright, hopefully these two cases are going to add to your knowledge pool now. So when you see different type of equations moving forward in this class or in any other math classes, you know that it could have a one solution, right? That what we're used to, because we've done one solution. You've seen no solution, and now you've seen infinitely many. So now you have the three potential cases, guys. There'll be some equations later on that are a little more complex, but you won't see any in this class. It'll be more likely in your next math class. All right, let's move on. We're done with the first lesson. We're on 9.5 now. Formulas is 9.5, formulas and problem solving. So pretty much in this lesson, you're going to be given a formula, different formulas in mathematics or science, and your job is to use these formulas with what they give you and find for the missing one. So substitute the given values into the formula, solve for the unknown variable. So we know d equals r times t. So this is a formula for distance. Distance is equal to rate times time. Rate times time. So let's figure out what this is. So the rate we know is, or distance is 31,000. So we're plugging in D. 31,680 equals 400 times T, because RT, they're being multiplied. We want to solve for the unknown variable. What's the only unknown we don't know? We don't know T. So now we use algebra to get T by itself. Since 400 and T are being multiplied, we're going to go ahead and divide by 400 on both sides. This becomes 1. Then we get T by itself. With my calculator, 31,680. I don't have one, so let me use it real quick. So 31,680 divided by 400 is 79.2. Now you can plug it in to test it out if you like, but we should be more confident in our solving skills, so we should be done at this point. So T equals 79.2 when the rate is 400 and the distance is 31,680. Let's go ahead and move on. So it's the same concept, but we have different formulas. Example, substitute the given values into the formula, solve for the unknown variable. We know perimeter is equal to 2 times the length plus 2 times the width. They give us the perimeter and they give us the width. So let's go ahead and plug that in, guys. So then we get 140 equals to 2 times L plus 2 times 30, because the width is 30, right? So let's simplify this. So 140 is equal to 2L plus 60, right? 2 times 30. We want to solve for L, right? L is the unknown thing here that we don't know. So we're going to go ahead and subtract 60 on both sides. So then we get 80 equals 2L. 2 times L, the opposite of multiplying 2 is dividing 2. So we can say that the length L is equal to 40 feet. And we are done. Make sure you have the unit 2 to know the difference, guys. All right, let's go ahead and move on. Okay, that's a copy one. Let's ignore that one. So here's the next example. Remember to pause if you need time to write this down. F equals 9 over 5c plus 32 for F equals 59. So we're going to get 59 equals 9 over 5c plus 32. So we do have a fraction, so we could multiply it by the LCD, but let's get c by itself first. So let's subtract 32 first on both sides. This becomes 0, so then we get 27 is equal to 9/5 c. We're going to go ahead and multiply the whole thing here by 5 to cancel out the 5 in the bottom here. So draw your 2 arrows. So 27 times 5 is 135. And then when we do 5 times 9, 5, the 5s are going to cancel out. So then we get 9c. Divide both sides by 9. So then we get that the Celsius degrees will be 135 divided by 9, which is 15 degrees Celsius. So this is converting for Fahrenheit to Celsius, guys. Make sure you rewatch this if you didn't follow with the steps. See what I did again. Make sure you're understanding that and use this homework for practice problems. So here's this example problem real quick, guys. The length of a rectangular road. So this is a word problem. So the length of a rectangular road is 2 feet less than 3 times its width. We want to find the dimensions if the perimeter is 28 feet. So we know it's perimeter, so we know it's P equals 2L plus 2W. We also know the perimeter is 28 feet. We know that the length, right here, the highlighted part, the length is 2 feet less than. 2 feet less than, so subtract 2, 3 times the width. And the width is just W. Now let's plug this into the formula. So then we get P is 28, right? So then we get 28 is equal to 2 parentheses 3W minus 2 plus 2W, right? Because that's the formula. We plug this in for L and this in for W. And plug this in for P. And that's what we have here. We have P, L, and W. Now it's solve for W because it wants us to find the dimension. So distribute the 2. So then 2 times 3W is 6W. 2 times minus 2 is minus 4 plus 2w, bring down to 28. Combine the like terms, and we're going to get 8w minus 4, bring down to 28. Add 4 on both sides. So then we get 32 equals 8w. Divide both sides by 8, and then we get the w is equal to 4 feet. So now we know what this is. This is 4 feet. We're done here. But they also want us to find the length as well, right? So to find the length as well, let's plug in w, right? We know w is 4. So it's going to be 3 times 4 minus 2, which is 12 minus 2, which is just 10 feet. And that is how you find the length and the width. So make sure you read the problem again and watch this process again to see how I broke down the steps and got the width and the length from just having the perimeter and knowing the formula. Alright guys, you're doing great so far. So here's a practice problem from this one. So it says the length of a rectangle is 1 meter more than 4 times its width. Find the dimensions if the perimeter is 52. So we know P is equal to 2L plus 2W. But this problem tells us P is 52 meters. Tells us that the length is 1 more than 4W, or just 4W plus 1. The length is. So let's plug that in. So we know 52 is equal to 2 parentheses 4W plus 1 plus 2W. Distribute the 2, and we get 8W plus 2 plus 2W, bring down to 52. Subtract 2 on both sides, and we get 50 equals 10W, because I forgot to combine the 8W and the 2W. Divide both sides by 10, and then we get that the width is 5 feet. So now we just got to plug it to find the L, plug it in for W. So it'll be 4 parentheses 5 plus 1, which is 20 plus 1, which is 21 feet, which is the length. So now we found the dimensions of this rectangle. So make sure you take a step back, guys, and look at how to read the problem. We've seen these components in this class. I showed you how to write expressions from sentences. I showed you how to solve for equations. So you know all the resources to do this. You just need to apply it now. This is what we're doing. So let's keep going. So here we have solved the equation for the given variable. So here you're going to see multiple equations, and your job is to get that letter by itself. So look at this first problem here. Solve V equals L times W times H for L. So since all of these are being multiplied, what's the opposite of multiplication? We're going to divide both of these sides by W and H. This is going to cancel out the W and H, and we're left with L is equal to volume over width times height. And you're done. So now look over here at B. Solve y equals mx plus b for x. So to get x by itself, so go ahead and move with the line down the equal sign. Subtract b on both sides. This becomes 0. These are not like terms, so then we get y minus b is equal to mx. They're being multiplied, so we have to divide both sides by m, since we want to get x alone. It'll be y minus b over m, and we are done. So just keep in mind, it's just algebra, but now there's no numbers involved. But it's the same properties we've seen. So perimeter, so look at C. Solve P equals 2L plus 2W for W. So that we're going to get W by itself, right? So since 2L is positive, I'm going to go ahead and subtract it. So it'll be minus 2L. And I'm going to do that on the other side over here. This becomes 0. But I get perimeter minus 2L is equal to 2W. I want to get W by itself, so I'm going to divide both sides by 2. So then giving me that the width is the perimeter minus 2 times the length over 2. And we're done. Alright, let's look at D. We have solve F equals 9 over 5 C plus 32 for C. So we're going to go ahead and subtract by 32 on both sides. So then we get F minus 32 equals 9 over 5C. And then we're going to go ahead and multiply both sides by 5, right? Because we're dividing by 5 because we want to get the LCD, right? Get the fraction out. So it'll be 5 parentheses that times 5 here. Cancels out the 5. And then we have 9c, right? So then we get 5 parentheses f minus 32 equals 9c. Divide both sides by 9. And we're done. We get c is equal to 5 parentheses f minus 32 all divided by 9. And we're done. So don't overthink these problems, guys. Don't just go ahead and write them down and manipulate them the way we know how. I've shown you the steps in multiple examples over the lectures in this class, so you should be okay with what we've seen so far. So go ahead and use these practice problems to get you exposed to different ways to see them, okay? So here, I'm going to go ahead and pause it, work through them. I'm going to go ahead and work through them real quick. So go ahead and pause it if you want to work on them on your own. So look at A. A is solve C equals 2 pi r for r. Well, 2 pi r are being multiplied to r. All of them are being multiplied. So the opposite of multiplication is division. So go ahead and divide both sides. Then we get the radius is circumference over 2 pi. And we're done. B wants us to solve for length from a perimeter equation. So we want to get L by itself. So now we're just going to go ahead and move 2W on both sides. So then we get P minus 2W equals 2L. Divide both sides by 2. And then we get L is equal to P minus 2W over 2. And we're done. Then we have over here P, C. P equals 2A plus B minus C for A. So we want to move all of this and get A by itself. So first, let's go ahead and move B by subtracting it. So then we get P minus B equals 2A minus C. When it gets A by itself, so we're going to go ahead and add C now. So then we get P minus B we get P minus B plus C equals 2A. Divide both sides by 2. And then we get A equals P minus B plus C over 2. And we're done. Look at D. D is solve A equals A plus B over 2 for B. So to touch this B first, we can get rid of this dividing 2. The opposite of dividing 2 is multiplying 2 on both sides. So that cancels out. So then we get 2A equals A plus B. Now to get A by itself, move little a to the other side. So then we get B equals 2 big A minus little a. And we are done. So be very conscientious about the steps that you see, guys. It's not too intense. It looks intense, but do not be intimidated by this. You guys are growing so much as students. All right, let's go ahead and keep going. And we're on the last lesson of today. So here we are at 9.6 linear inequalities, guys. So linear inequalities is 9.6. So before we get into linear inequalities, it is important you know the symbols. So it's very important that you remember that less than is pointing to the left. Right, when it points to the right, it's greater than. When it has the line in the bottom, it's less than or equal to, or greater than or equal to. Now, little things I want you to write over here. With less than or greater than, I want you to put an open circle and parentheses. And less than or equal to, I want you to put a closed circle, and I want you to put brackets. These symbols are going to correlate with these inequality symbols, okay, guys? So you can draw a line to separate them. Let's go ahead and see what I'm talking about, right? Look at the first example of today's lesson. Graph x is greater than or equal to -1. Write the solutions in interval notation. Then write the solutions in interval notation. So graph this line. So this is saying x, so every mathematical inequality, it's a statement. It's a sentence. It's a statement. So this is saying x is greater than or equal to -1. So what does that look like in a number line, right? So it wants us to write the solutions. It wants us to graph it first, right? So we have this graph. 0 is always in the middle of the number line. -1 is right here. And we have all these other numbers, right? But I'm not going to write all of them just because we're in college. And you could write all the number lines if you want, like 1, 2, 3, 4, 5, whatever. It's up to you. Like it'll be 1, 2, 3, 4, whatever. You can do what you want. So the first thing I want you to do is -1, right? So it's greater than or equal to, right? So greater than or equal to means it's going to be a closed circle here at -1. And then it's greater than. So what numbers are greater than to -1? Well, 0 is greater than. Positive numbers are greater than -1. So we're going to go ahead and go to the right side of the number line. Now, I learned it where you color the number line. I've seen people do it on top of the number line. I've seen multiple ways. Now, what's the solution in interval notation? So I want you to draw a closed circle, and I want you to also, since it's closed, it's going to be a bracket symbol. And since we're going to the right, we're going to use this bracket symbol over here. So we know it starts at -1, right? So what's now we want to write interval notation, right? Interval notation is just made up of brackets or parentheses and symbols, right? So since we're starting at -1, we're going to go ahead and close it off with the bracket. And look at where it's going. This arrow, what number does it stop at? This arrow means that it's never going to stop, right? Because 100 is greater than -1, 1,000 is greater than -1, 1,000,000 is greater than -1. So this can go all the way to infinity, ladies and gentlemen, infinity. This is actually known as positive infinity. You don't have to write the positive sign, but being on the right side, it means it's positive. And always put parentheses with infinity sign, guys. So this is the interval notation. And this is the graph. The graph is a number line, ladies and gentlemen. So that's what we're going to have to do in this lesson, but it is going to get a little more complex as the lesson continues, guys. So let's go ahead and push through it. This will be your practice problem for this one. So graph x is greater than or equal to -2. Write the solutions in interval notation. So x is greater than or equal to -2. So it starts at -2 right here. And it's greater than. So what numbers are greater than? All to the right. And then don't forget to draw your arrow. Now, remember, it's a closed circle, right? And it has the equal to, so it's going to be a bracket as well. So get used to drawing both of these in the assignment, so that way you can know how to draw your interval notation, right? So we have the graph done, right? The graph is good to go. The interval notation, however, we start at -2, and since it's equal to, it's going to be a bracket, not a parentheses. And it's going to the right to positive infinity, so infinity and circle. And we're done with this practice problem. So take a second, guys, rewatch this if you need to. Let's look at these next two examples. So A, graph -1 is greater than x. Write the solution in interval notation. So we want to graph it first. -1 is greater than. Uh-oh, how do I write this? It's not like before. Well, guess what? This can be rewritten actually. If -1 is greater than x, -1 is greater than x, that's the same thing as saying x is what? If -1 is greater than x, so -1 is going to always be bigger than x, that's saying that x is also less than -1. So if you want to know the trick, you will flip these two, flip those two, and then flip the symbol as well. But you don't need to think about it like that. Just read it to yourself logically. -1 greater than x is the same thing as x being less than -1. Since -1 is greater than. You know what I mean? So just read that to yourself over and over again till you get it like this. Because that way you know how to graph a number line like that. So x is less than -1. So this is 0, -1's right here. Since it's the less than, it's going to be an open circle because we're not including -1. The closed means we're including -1. Open means we're not. And it's less than. So the more negative we go, the more less it is. So it's going to be a parentheses this way and going this way as well. So there's two ways to draw this, right? Well, what's the interval notation? Well, which infinity is to the left? So -100 is less than -1, -1,000 is less than -1, -1,000,000. So it's the same thing as saying negative infinity, comma, -1 parentheses. This is your interval notation. So look at B. Now B is a little interesting because now we have x between two different values, right? So let's go ahead and graph this. So x. So let's read this first. This is saying -4 is less than x, less than or equal to 2. So let's go ahead and draw my number line, right? And we're going to see x is, so we have -4 here, 0 right in the middle, and then 2. Well, 2, we're including it because it has the equal to, but -4 is open because it's a less than. And let's go ahead and connect in between because x is between these two numbers, right? So now how do we write that as an interval, right? So -4 is a parentheses, right? Because it's an open circle, but it stops at 2. But it includes 2, so it has to be a bracket. So it's all about reading the numbers we have here, right? So -4, -4, -4. We have 2, 2, and 2. The symbols is what tells us what kind of, these is tells us what kind of dots it's going to be and what kind of symbol this is going to be. So all of this is related, guys. Is make sure that you understand and you write down every example as you should. That way you can get exposure to all of this as much as you can. Let's go ahead and push through it. Here's some practice problems. Go ahead and pause to give it a shot here. So A, graph 5 is greater than x. 5 is greater than x. Write the solutions in interval notation. So we're going to graph it first. 5 greater than x is the same thing as x is less than 5. So just go ahead and go to -5 here. It's going to be an open circle, right? Because it's less than. And we're going to go all the way to the left. And then go ahead and graph that. It's going to be a parentheses going all the way to the left side. Well, we know to the left is a negative infinity, and it stops at +5. But it's not including 5 because it's an open circle, and it's just a less than. So it's just going to be a parentheses symbol here for interval notation. Let's look at B, right? B has -3 less than or equal to x less than 1, right? So we know, look at the symbol. So it's going to be between -3 and 1. So it's going to plot our point. So -3 is it's closed, right? Because it has the equal to. 1 has an open circle. Now go ahead and put that in there real quick. Now if you want to draw the symbol, so you know it's going to be a parentheses and then a bracket over here. So it'll be bracket -3, comma 1. Now, there's a lot of little techniques you can follow to kind of figure out the interval notation, how to get the graph going. Up to you, whichever one works, guys. Rewatch this component or this lesson if you got lost or confused with the graphing and the manipulating, because it is going to get a little more challenging in the next other slides, guys. So let's keep going. Well, in this example, it says solve x plus 4 is less than or equal to -6. Grab the solution set and write it in interval notation. So now we have algebra involved with these inequalities. We have x plus 4 is less than or equal to -6. So we want to, I want you to treat this symbol, the inequality, whatever it is, the less than, as an equal sign for now. So pretend it says x plus 4 equals -6. Well, we want to solve for x, right? So to get x alone, we're going to go ahead and subtract by 4 on both sides. When we do that, that becomes 0. So then we get x is less than or equal to -10. X is not by itself. Now we can graph this. This is what we're used to graphing. So get your number line. That's not a number line. That was meant to be an arrow. Don't judge me. So then we're going to go to -10, right? This is going to be 0. I'm going to say this is -10. Well, it's less than or equal to, so we know that we're going to include that point there. And we're going less than, so that's going to be to the left, ladies and gentlemen, to the left. I'm going to go ahead and switch my colors real quick. So make sure you do that. And then we know it's going to be a bracket, right? Bracket because of the less than or equal to. So how do we write this as a interval notation? Well, it's going to the left, and we all know the left is negative infinity with the parentheses, and it stops at negative 10 with a bracket, right? So make sure you're following the correct symbols. Remember that infinity has always has a parentheses next to it, okay, guys? A parentheses next to it. All right, let's go ahead and keep going, guys. We're almost done. Or more, we're almost done. So there's your practice problems. Solve x minus 6 is greater than or equal to negative 11. And then graph it on the interval on the set, and then write it in interval notation. So we have x minus 6 is greater than or equal to negative 11. Go ahead and pause it here. Remember to treat this as an equal sign. So go ahead and add 6 on both sides. Zeros out, so x is greater than or equal to negative 5. So we have this solution to graph. So x is greater than or equal to negative 5. So it's going to be a closed circle going to the right, guys, which is going to be a bracket going to the right. So we're going to start at negative 5 with a bracket, going to positive infinity with a parentheses, and we are good to go, guys. Good to go. Let's keep going. So note, when you multiply or divide by a negative number, the inequality symbol is going to flip. So what does that mean, right? So we have negative 2x is greater than or equal to 10. So we're going to go ahead and divide both sides by negative 2 because to get x alone, right? Because negative 2 times x. These cancel it out. Give me x. We're going to flip this greater than to a less than or equal to negative 5. So we have to flip it. That is very important. Here we're dividing by a negative 4, so we're going to multiply by a negative 4. It cancels out, so we get x is greater than negative 12. See how it flips. So remember that rule, guys. That's going to be true for all cases, and it's important that you remember that as you move on in this lecture. So we have some examples seeing that real quick. So look at example A. Negative 2x is less than or equal to negative 4. So negative 2x is less than or equal to negative 4. Divide both sides by negative 2. So then we get x is greater than or equal to positive 2. So we have the solution. So now we're going to graph it. I'm so bad at arrows. So we're going to draw the solution. So draw your number line. We know zeros here, and it's going to be at positive 2. You don't have to write all the lines. This is the college format. You can be lazier about it. If you want to do every number 1, 2, I don't. It's up to you guys. Whatever makes you feel better. So it's going to be x is greater than or equal to 2, right? So put a closed circle, and it's greater than, so we're going to be going to the right, to the positive side. So right there. Let me just change the color. We know it's closed, so it's going to be a bracket to the right. So the interval will be bracket 2 to positive infinity parentheses. Let's go ahead and look at B. 2x is less than negative 4. Graph the solution set, write it in interval notation. So we have 2x is less than negative 4. Divide both sides by 2. So then we get x is less than negative 2. The sign stays the same because we only divided by a positive 2. Do not fall for that trick, class. So then 0, we have negative 2. So we're going to go ahead, it's less than, and so it's going to be an open circle, and it's less than, so it's going to be going to the left. So when there's going to be a parentheses going to the left, the arrow is to the left, so it's going to be a negative infinity to a negative 2. And we are done, guys. So take a quick moment to see how I did this real quick. Rewind this if you have to. Let's go ahead and move on. We have some practice problems here, guys. So pause it here to work through it, and then press play once you're ready to see me work them out. So negative 3x is less than or equal to 12. And I'm sorry if I sound like I'm rushing, guys. My laptop is about to die, and my tablet is too, so I'm trying to be quick. So we have negative 3x is less than or equal to 12. So negative 3x is less than or equal to 12. Divide both sides by negative 3. So then we get x is greater than or equal to negative 4. The sign flip because we divided by a negative 4. So then we get negative 4 is greater than, so it's going to be to the right. It's going to be a bracket as well. Bracket to the right. So that means it's going to be bracket negative 4 to positive infinity, and we are done. Look at B. So B, we have 5x is greater than negative 20. Divide both sides by 5. So then we get x is greater than negative 4. The sign does not flip because we did not divide by a negative. So then we're going to go ahead and put it here at negative 4, open circle, and this will be going to the right. So it's going to be a parentheses to the right, which is going to be parentheses negative 4 to positive infinity. And those are how you write interval notation, guys. Hopefully, you're starting to make sense of when to use positive infinity or negative infinity, brackets to parentheses, guys. Because it's just gonna get a little harder, the algebra. But keep with me. You guys are doing great. So we're here at negative 4x plus 7 is greater than or equal to negative 9. Graph the solution set and write it in interval notation. So we have negative 4x plus 7 is greater than or equal to negative 9. So go ahead and solve for it. Remember, I want you to think about this as equal to. So draw the line down here. Subtract 7 on both sides. So we get negative 4x is greater than or equal to negative 16. Divide both sides by negative 4. We're dividing by a negative. So we get x is less than or equal to positive 4. We have the solution set. So now we have to write it in interval notation. It wants us to graph it too. So get your number line. So 0 in the middle, 4 is over here to the right. So it's going to be less than or equal to 4. So we're going to include 4. So draw a closed circle. And then draw your arrow because it's not going to stop, right? So it's going to be a bracket to the left. So it's going to be negative infinity to positive 4 bracket. And we are done. So I want you guys to see how we solve for x like an equation. And then use the inequality symbol to pretty much get it there to where it's at. Alright, so here is the practice problem, guys, or another example actually. I'm going to let you guys write it real quick. I'm going to get my charger. 1 second. Alright, we're back online, guys. Let's go ahead and I'm going to take my time now since I have my charger. Alright, so see how it's getting more complicated now, the inequalities. Inequalities is just a different type of algebraic expression. What are expressions? There's expressions, there's equations, and now there's inequalities. But they are mathematical statements. So remember, we're going to treat this as an equal sign. So distribute your 2. 2 times x is 2x minus 6. Bring down everything else. Now let's go ahead and manipulate it and get x by itself. So subtract 2x's on both sides. Now remember, now this one, you want to put the x to the left so you don't have to rewrite it. Could you move it to the right side? Yes, you could, but the logic will be a little more complicated. So this becomes 0. Negative 7x plus 7 is less than negative 6. Subtract by 7 on both sides. So I get negative 7x is less than negative 13. Divide both sides by negative 7. And we get x is greater than 13 over 7. And we're done. And it wants us to graph it and write it in interval notation. So number line. So 13 over 7 is like a positive number, so I'm going to put 0, and I'm going to put over here just 13 over 7. It's greater than, so it's going to go ahead and be a open circle to the right because it's greater than, right? Every number to the right of something is greater than, like 1, oh not 1, but 5, 10, 100, million. And since it's an open circle, it's going to be a parentheses with an arrow. So it'll be parentheses 13 over 7 all the way to positive infinity. So this example was mainly put in here so you can notice that we're gonna have fractions and decimals as solutions in your inequalities as well. Everything is free game now since you're being exposed to more different types of examples. So let's go ahead and solve this one over here, guys. So this gets a little, look how more intense it gets, right? Look how beautiful this looks. So 2 parentheses x minus 3 minus 5 is less than or equal to 3 parentheses x plus 2 minus 18. We're going to go ahead and solve this, right? So distribute your 2. Excuse me. 2 times x is 2x. 2 times minus 3 is negative 6. Minus 5 less than or equal to distribute your 3. So we get 3x plus 6 minus 18. Combine your like terms. Negative 6 minus 5 is 2x minus 11. Here, 6 and minus 18. You owe me 18, but you pay me 6, so you still owe me $12. We're going to go ahead and subtract 3x on both sides. So then we get negative x is minus 11 less than or equal to negative 12. I'm going to add 11 on both sides. So we get negative x is less than or equal to negative 1. Divide both sides by negative 1. So the sign flips. So we get positive x is now greater than or equal to positive 1. And we're done with the solution set. But it wants us to write it in interval notation. So I'm not going to graph it. So since I know it's greater than, it's going to start at 1, right? Because x is, what's greater than 1? 2, 3, 4, 5, 10, 100, million, infinity. So it's going to go all the way to infinity. And we're done. Now, if you can't go from the inequality to the interval notation, graphic, guys. You can a picture's 1,000 words if you have to. You have to do what you have to do. All right, so now we're to the last 3 practice problems, guys, and you're done with today's lesson. So here we have negative 3x plus 11 is less than or equal to negative 13. Graph the solution set and then write it in interval notation. So you have the equation up here. Bring it down here so I can solve it. Remember, positive, you want to work it out yourself. Minus 11 on both sides. Yeah, negative 3x is less than or equal to negative 24. Divide both sides by negative 3. So get x is greater than or equal to positive 8. So it's going to be starting at positive 8. And it's greater than, so it's going to be going to the right. So there's going to be a bracket to the right. So be bracket 8, comma, infinity. That looks very ugly because it looks very similar. Let me change it up. Let's try it again. So this will be bracket numero 8 to infinity. All right. Here's another practice problem, guys. Remember to try these out by yourself and then watch me work through it to see if you can match my answer as well, guys. So then here we have 2x minus 3 is greater than 4 parentheses x minus 1. Go ahead and draw the line down here. Distribute your 4. Then we have 2x minus 3 is greater than 4 times x is 4x. And then 4 times minus 1 is negative 4. So to get, I'm gonna show you on this practice problem to move it to the right. Why you don't want to do that, because it's gonna be an extra step. So subtract 2x's on both sides. So then we get negative 3 is greater than 2x minus 4. Add 4 on both sides. So then 0. So then we get 1 is greater than 2x. Divide both sides by 2. So then we get 1/2 is greater than x. I don't know how to graph this, so guess what? We have to rewrite this. 1/2 greater than x is the same thing as x is less than 1/2. So that's an extra step that we can avoid by just moving x's to the left, guys. I should have done this as an example, but my apologies. So we want 1/2, right? 1/2 is between 0 and 1, and it's an open circle, right? Because of the it's less than, right? And it's to the left because it's less than. You can go this way, it's pointing to the left, and it's gonna be a parentheses to the left. So it'll be parentheses negative infinity to 1/2 parentheses, and we're done. All right, guys, the last practice problem of the day. So it's a pretty long one. A beautiful monster that I like to call it. Pause it here, try to work it out. I'm gonna go ahead and rewrite it real quick before I get on this. Make sure you guys are able to follow with me the steps that I'm doing. Nothing is new here. We just have this symbol that's new. So we're going to distribute the 3. 3 times x is 3x. 3 times 5 is 15. Minus 1 is greater than or equal to. So distribute the 5. So then we get 5x minus 5 plus 7. Combine your like terms, right? We can combine the 15 and minus 1 and the negative 5 and 7 over here. So 15 minus 1 is just 14. And then we have negative 5 plus 7 is just plus 2. Subtract 5x on both sides. So then we get negative 2x plus 14 is greater than or equal to 2. Subtract 14 on both sides. So then we get negative 2x is greater than or equal to negative 12. Divide both sides by negative 2. So then we get x is less than or equal to positive 6. And as a solution set without the number line, I'm going to go ahead and just write is less than, right? It's moving to the left side. So it's going to be negative infinity, but it's going to stop at 6. And we're done. Remember to graph the number line if you have to, guys. I do apologize if this video was sim rushed to you. Just you can lower the speed, or you can hopefully just pause it and rewind it. Do what you have to do. I'm so sorry for missing the lecture. Thank you guys for tuning in. Good luck with these homework assignments, and I'll see you in class next time.